Alright, so today we're going to look a little bit about an area of quadrilaterals. Quadrilaterals are polygons with four sides. Specifically, we're going to look at squares, rectangles, parallelograms, and trapezoids. So to start off with, we will put our square right there. Now when we are talking about a square, right, it has four congruent sides, four right angles, and we are going to call this measurement right here the length. We're also going to put the same length on the bottom because they are congruent sides. You'll notice that I'm using a kind of a cursive L for that. You usually use that just in geometry so it doesn't end up looking like a 1. But right here, area equals length times length, or length times A equals L times L, or A equals L squared. So if we had a square, we would simply take our equation, A equals L times L. We're going to substitute in the values. We can look, our length is 4. So then I'm just going to replace the L with 4. A equals 4 times 4. And so A equals 16 centimeters squared. We always put centimeters squared, or whatever the area is, squared when we're talking area, because it's a two-dimensional thing. If we're just talking a distance, then it's just there's no exponent there. A rectangle is very similar, obviously, to a square. We've got our length again, and then we call this dimension right here when we're talking about rectangles the width. So we've got our length and our width. Just like a square, we just multiply those two things by each other to find the area. So area equals length times width, or L times W. So let's say I have my rectangle right here. I'm going to just put my equation, A equals L times W. My width is the 7, because that's left to right. My length is the 5, that's up and down. So I'm just going to put those values in there. A equals 5 times 7, or A equals 35 inches squared. So that's our area. Sometimes you'll be asked to kind of work backwards. And so let's say you had the area was 56, and then you were told that the length was unknown, that's just an L, and the width is 7. I'm just going to use that same equation. Area equals length times width. I'm going to substitute in the values I know. So I have 56 equals L times 7. And so if I want to solve now, I have a one-step equation. What times 7 equals 56? I could also just divide both sides if I'm solving algebraically. That cancels out the 7s, and that gives us with L equals 8. And so our length would be 8 in this situation. So that's area of squares and rectangles. Now, the next type of quadrilateral we're going to talk about is a parallelogram. A parallelogram is kind of like a rectangle that's been squished. We see that we have sides that are congruent to the opposite sides, and we see that the sides are parallel to each other. For some reason, we sort of switch what we call it, but we call that, instead of calling it the width, we call it the base. Now also, when we have our parallelogram, the important measurement to know is actually the height. Now the height of a parallelogram would be from the top straight down to the bottom. It's not going to be this diagonal measurement right here. So if you think you're taking your height, you don't measure from the top of your head out to the like a diagonal point, you just measure straight down. So often what we'll see is like a dotted line kind of going down like there, or maybe a dotted line going down right there, and that's our height. Okay, so you'll usually be given that measurement. And then what you can do is to figure out the area of a parallelogram, we're gonna take a little GIF right here that I found online. You can actually see if you cut the side of the parallelogram off and then shift it over to the right side, it then turns into a rectangle. In which case, if you've got a rectangle, you're just going to multiply that dimension right there by that dimension right there. In this case, we're calling that the base times the height. So our area equals base times height, or you could say A equals B times H if we're using variables. So here's our example of our parallelogram. We're going to look for our things. So we're going to say A equals base times height. In this one, we can see our base is 6, And then our height is not going to be this diagonal, but our height is going to be this up and down right here, this 2. So we just need to do then A equals 6 times 2, or the area equals 12 inches squared. Now sometimes you'll be given a parallelogram, it'll be turned on its side or it'll be angled. Again, the main things you want to look for is you want to look for what's the base, the part that you would lay it flat down, and then up, straight up and down. So even though this is the bottom right here, we can see that we do not have a straight up and down measurement kind of going from that. It's not laid flat down. So, but if we were to take this and we were to kind of tilt it over, or turn it over, we would see that we've got our base right here and that we've got our height right here. So then we would use our equation. Area equals base times height. Our base is 10, so A equals 10 times our height is 3. The area equals 30, in this case, meters squared. And then our last shape is going to be a trapezoid. A trapezoid is a little different than a parallelogram because it only has one set of parallel sides, just the top and the bottom. The left and the right might be congruent, but they don't have to be. And so in this case, you can see they are not. And so if we want to find the area of this, we're going to think of a couple measurements. Now, we're going to call this part right here a base. We're actually going to call it base 1. You'll see I put that little 1 right there. It's called subscript. And then we call the top, not the top. It's kind of funky. We're going to call it base 2. So we're going to say there's 2 bases. Now, technically, you could flip that trapezoid upside down. So we'll define one as base 1, one as base 2. It really doesn't matter which one you call at the end of the day. And then the third measurement that we need to know is that height measurement, which again is going to be the measurement straight up and down. That's our height right there. So if we were to find the equation for the area, the way we do this is we actually take one trapezoid and then we're going to take a copy of it and flip it upside down. And so you can see I've done that right there. And if you do that, now if you look, you can actually see that it looks a lot like a parallelogram, just like right here. And we know the equation for a parallelogram is this measurement times this measurement, the base times the height. So to find that for our trapezoid, we're going to recognize we've got our area is going to be base 1, right, which is actually right here. This is base 1. We've got our base 2 is this part right here, base 2 and base 2. So if we want to use the full base, like with a parallelogram, we're going to add these two together. So base 1 plus, and we'll do base 2. And then we're actually going to multiply that by the height. See if I can squeeze it in there. And then, so that would tell us the area of this thing, but we want to know only the area of one of them. So we're actually going to divide the whole thing by 2. So if we were to put that as an equation, we could say A equals B1 or base 1 plus base 2, multiply that whole thing by the height, and then divide by 2. Sounds a little more complicated than it is. So let's look at one example. If we have this right here, we can see that we've got our base 1 right there. We can see we've got our base 2 right there. And we can see we've got our height is the one that's going to be not that one or this one, but the straight up and down one. So that right there is our height at 10 centimeters. So then we will just use our equation. We have area equals base 1 plus base 2 times the height divided by 2, and I'm going to substitute in my values now. So area equals base 1 is 20 plus base 2 is 6. Put those in parentheses. We're going to multiply it by the height, which is 10, and then we'll divide the whole thing by 2. We always follow order of operations, which we do parentheses first. So if we do show all our work here, we'd have 26 times 10 divided by 2, or 260 divided by 2, which will ultimately equal 130 centimeters squared would be our area for that. So we just take basically the top and the bottom, base 1 and base 2, add them together, multiply that by the straight up and down height, and then divide the whole thing by 2. And that's how you find the area of squares, rectangles, parallelograms, and trapezoids.